Hi everyone, my name is Jun Kirby Arinolos and I'm here to report our output in navigational instrument. And our topic is gyroscope control and dumpling arrangement. Alright, so I show you a couple of scenarios from which you can understand what this movement is. So the movement about the horizontal plane is known as a drift, and the movement about the vertical plane will be known as a tilt. So these are the two movements of the gyroscope or axis of the gyroscope, because of which it doesn't stay pointing in one direction. And because of this drift, until the gyroscope makers had to develop methods to counteract from this drift until so that gyroscope axis can remain horizontal and pointing towards one direction all the time. So that is can be used for direction keeping and course measurements. Let's start with the first movement of drift. To understand what is drift is, imagine that a gyroscope is placed on the pole of the earth right on the top of the pole of the earth. And I made the gyroscope spin axis horizontal. You see the yellow line? That's the spin axis, so it make horizontal. And I make it point towards one face star. Ideally, if the earth was not spinning, the gyroscope would have kept pointing towards a fixed star. But the earth is not stationary. It keeps moving around its axis, because of which he has observed while not that this star is moving with respect to us, instead of realizing that star is fixed and we are moving the sun. The earth moving is so slow that we think that is the state that's moving. So why even the gyroscope axis will trace the movement of these stars. However, on the pole, you will not see the body rising or sitting. All you will see is the body going round. You will see because you are stand right on the top of the earth, right? And that's what gyroscope axis does. Will it basically trace the movement of the stars, but in one direction only, that is the movement about the horizontal axis. So it's go round, round, and round. But this is now no movement about the vertical axis. The movement is horizontal axis because we right at the pole. So for us at the pole, there is no rising or sitting or body. Basically, the body is just going round and round. About this horizontal axis of gyros is now known as a drift.
Good day, everyone. I'm here to report gyroscope control and damping arrangement. So, topic objectives: discuss gyroscope, describe the use of gyroscope, and determine how it works in the ship or on the ship. So, gyroscope. The term gyroscope conventionally conventionally referred to a mechanical class of gyroscope derives from the ancient Greek language, being the physics of the precession motion, a phenomenon also observed in ancient Greek society. So gyroscope are devices mounted on a frame and able to sense an angular velocity if the frame is rotating. Many classes of gyroscope exist depending on the operating physical principle and the involved technology. Gyroscope can be used alone or included in more complex systems, such as gyrocompass, um, inertial measurement unit, inertial navigation system, and attitude heading reference system. Oh, a gyroscope is a device. Yes, device that consists of a wheel or disc or circulating beam of light mounted such that it can spin rapidly about an axis. This axis is free to change in any direction. the orientation of the axis is not impacted by the tilting of the mounting. So the gyroscope is in effect used to detect and measure the deviation of an object from its desired orientation, even maintain the set orientation and angular velocity. So how does a gyroscope work on the ship? Uh, a gyroscope compass is a form of gyroscope used widely on ship employing an electrically powered spinning gyroscope wheel and frictional forces among other factors utilizing the basic physical laws, influences of gravity and the earth rotation to find the true north. So tilt, what is tilt and how tilt work on the gyroscope?
Let's talk about tilt. It know what is tilt. Tilt is now the motion of the gyroscope axis about its vertical. So to understand what where it is, visualize a gyroscope made again to spin at its maximum RPM and need to point towards a fixed star in space. But this time the gyroscope is kept at the equator. It's not kept at the pole for us as observers on the Earth. Like I said before, when the Earth is spinning and as the Earth spins so slowly in views, observers move with the Earth for us when we come over to Brazil and we can see the sun. We think it is the sun that is rising, but it is not the case. It's us who are moving with the Earth and we can see an apparent motion of the sun rising and sun setting. Similarly, the same thing happened with the stars and other heavenly bodies as well. Now, if a gyroscope axis is placed on the equator, hence the Earth move of gyroscope of course will move of it. But since it's made to point towards a fixed direction and a fixed star, we notice as rising and setting of celestial bodies will physically notice a movement or an apparent movement of a gyroscope axis about its vertical plane because it will the body rising and setting all right, and this is the apparent motion of the stars that you will see in a similar motion will be also see of the gyroscope axis of the vertical plane as you saw basically the scope is tracing out the celestial body rising and setting. The same scenario can be viewed from below the South Pole as well. And you realize what I'm talking about here. So the tilt is the moving of the gyroscope axis about the vertical plane. Whereas the drift is the movement of the gyroscope axis only around the horizontal plane. Alright, so that is why the drift, which is the movement of the gyroscope axis around the horizontal plane, is observed for its maximum at the poles and it starts to reduce as you come down from the poles towards the equator and it becomes absolutely zero at the equator. Similarly, in drift is a function of latitude. Drift also equals 15 multiplied by sin of latitude per hour. So that will give you the drift. So if you actually measure it, you can see that at the pole whereas the latitude in 90 degrees 15 times sin of 90 degrees is 15 times 1 which is 15, and that's why drift is maximum at the pole. Whereas drift at the equator will be 15 times sin of 0 degrees latitude which m is 0.